Hello, in this video, I want to talk about the design and construction of a 3-frequency reciprocal frame geodesic dome model. It is also a trussed dome, meaning it has thickness, so it's much stronger than a thin shell. What's really interesting about this structure is that it has these very unique spiral joints, as shown in this middle picture here. To start off, we have a 1-frequency geodesic sphere, which is essentially just an icosahedron. As you increase the frequency, the structure becomes a better approximation of an actual sphere. Then you remove the bottom of the sphere to create a dome. To make it into a reciprocal structure, you need to rotate the struts and then extend the ends until they overlap. As you can see, without rotation, the struts just collide. But when you have too much rotation, the struts separate. The way I've dealt with this is to measure the average joint separation and minimize the absolute value and determine the actual rotation that you need. To truss the dome, an inner layer needs to be added somehow. The method I'm going to use is inspired by Berkeman's Reddit post and Paul Robinson's YouTube video. Basically, you can form an inner layer of larger triangles that are shown yellow here. They're connected to the outer layer at certain vertices. After I learned about this method of trussing, I tried it on my reciprocal frame dome model. It turned out that all the inner struts fit perfectly through the holes created by the outer layer at the vertices. It means a reciprocal frame geodesic dome could be trussed without adding complexity. In fact, this inner layer helps to reinforce the joint and makes it even stronger. It forms this very unique spiral joint, and everything just fits so perfectly. I just thought this is such an elegant way to create a trussed geodesic dome. Here I'm showing you the inner layer could be added to the outer layer simply by bridging certain vertices together. This implies during actual construction of a dome, the inner layer could be added to the outer layer really simply, and it could adapt to the shape of the outer layer. For those who want to build a 3-frequency geodesic dome, it's actually quite simple. It just has 2 building blocks, a pentagon and a hexagon. You can divide the dome into 5 levels, as shown by these 5 layers. The first layer has 1 pentagon, the second layer has 5 hexagons, the third layer has 5 pentagons, the fourth layer has 5 hexagons, and the fifth layer has 5 half hexagons. The rest of the video is about the construction of the dome model, and I will put the dimensions at the end of the video.